Okay, do you want to introduce yourself and the poster?
Sure. My name is Christopher Heelan. I'm a senior research associate at Brown University. I work in the Nurmico lab.
Okay. And what's your poster? What's your poster?
So what we're showing here is a mobile embedded system that we built. It's a neural signal processing system. And the idea is that it takes in full broadband neural data and processes all of that data in real time in a deterministic fashion. And so what we're showing here with this poster specifically is really the computational power that's enclosed within that system. We're using a new kind of system on chip made by a company called Xilinx. It marries ARM processing cores and FPGA fabric into one chip. And using that kind of system, we're showing here that you can scale the processing of it to basically well over an order of magnitude above what current BCIs are actually requiring in terms of channel.
Yeah, and you, that was my first question actually when I came up here. Is like you were talking about high channel count and what does high channel count mean? What does high channel count mean for you guys?
So for us right now, it's just over 6,500 full broadband neural channels, and so that's data that's sampled at 30 kilohertz.
Okay, and could this also be used in parallel? Could you have multiple of these devices?
Oh, absolutely, yeah. So it would scale, assuming that you could actually feed the data to this system. You could have as many of these as you wanted in parallel. Right now, the system is about the size of a brick. So a single system, you could imagine mounting that on a wheelchair. The next generation system is going to be about the size of a thick smartphone. And so that's going to be actually even more horsepower in terms of what it can compute, because that'll be using the next generation chips that Xilinx makes.
Okay. Very cool. And in terms of power, input, output, heat generation, all this kind of stuff, do you want to talk about that?
Sure, yeah. So right now the system is, when it scales the 6,500 channels, the zinc itself is burning up just over 2 watts. The simulations that we've run have shown that gets to about 28 degrees Celsius. And so it does get a little bit warm. Right now this system is all passive cooling. It's enclosed in aluminum enclosure that kind of helps sink that heat. The next generation system is going to have active cooling on board. And so that will have a fan on board.
Okay, cool. And what are some next steps in this research, and what are you guys thinking about next?
Yeah, so the next step, I actually formed a company that's going to do the next iteration of this. And so what I really want to do is take this kind of technology and start bringing it to labs. So the company is going to build the next gen system. Like I said, it's going to be smaller, more power efficient, and higher performance. And then I want to take that to labs and find out what their specific needs are and kind of customize that platform for what they need. At the end of the day, the application space is really open and closed loop BCI.
Wow, incredible. So what's the name of the company, and are you a PhD student, or what are you?
So I'm a senior research associate. I just graduated, so newly minted, yeah. And so the company's called Connexon Systems, and the next gen system should be finished by the end of the year.
Very cool. Very cool. Well, I wish you the best of luck, and I hope that these improvements can help the rest of the society as well.
Yeah, absolutely. The whole plan for this kind of work is to try to make these systems more practical. And so at the end of the day, we're trying to build a system that's suitable for everyday use.
Yeah, thank you.
Yeah, no problem. Appreciate it.